Now that you are very familiar with the properties of parallelograms, we're going to explore some of the specific types of parallelograms and apply the properties to the different proofs. So what is a parallelogram? It is a what? What do you remember? Give yourself a minute to write the properties of a parallelogram. Have you listed 4 properties? If a figure is a parallelogram, it must meet the same conditions as a polygon and the same conditions of a quadrilateral, plus 1 more. So it's formed by 3 or more segments or sides. Each side intersects exactly 2 sides. It has 4 sides, and the opposite sides are parallel. Do these reasons, these properties, match what you wrote? Make any corrections that you need to. Now let's take a look at specific types of parallelograms. A rhombus is a parallelogram with 4 congruent sides, and we can see that with the tick marks, that they're all the same. 4 congruent sides. A rectangle is a parallelogram with 4 right angles, and each right angle measures 90 degrees. Here, 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 and here. You probably already knew that one. A square is a parallelogram with 4 congruent sides and 4 right angles. And by now you know how to read the tick marks, you know how to read the angle symbols. These symbols are represented on this figure. So decide whether the statement is always, sometimes, or never true. A rhombus is a rectangle, always, sometimes, or never. And you probably said sometimes. A parallelogram is a rectangle, sometimes. A rectangle is a parallelogram, always. A rectangle is a square, sometimes. And a square is a rectangle, always. So let's take a look at a figure here. ABCD is a rhombus. What do we know about it? The 4 sides are congruent. The opposite sides are parallel. The opposite angles are congruent. And the consecutive angles are supplementary. So what does that look like? They're congruent. That means they're all the same side length. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. And opposite angles are congruent. Now what does that supplementary mean? It means the two angles add up to 180 degrees. What do we know about the diagonals of this rhombus? Well, for one thing, they bisect each other. And the other thing about diagonals in a rhombus is that they're perpendicular. So we'll just draw this out. Oh, let me erase that. A little better. One diagonal, another diagonal. Each part is the same length because that's the definition of bisect. And they are perpendicular, which means that they form right angles. I'm not going to try to squeeze that in. Are we ready for a proof? Given that ABCD is a rhombus, prove that BD is perpendicular to AC. So BD is our line here, and we want to prove that it's perpendicular to AC. When we write our proofs, we start with the statements. ABCD is a rhombus, and that's given. Then we can write that segment AB is congruent to CD by definition of a rhombus. So let's see if I can highlight that for you. AB is congruent to CD. My next statement is that diagonals bisect each other because ABCD is a parallelogram. So the distance from A to M, and let me just go back here, we're going to mark M as being the point in the middle. From A to the middle, or midpoint, is congruent from C to the middle, and from the middle to B is congruent from the middle to B. Therefore, the triangle that has been created by the diagonals, known as AMB, is congruent to triangle CMB because we've proven that the three sides are congruent to each other. Side, side, side congruent is postulate. And therefore, AC is perpendicular to BD because the angles, the corresponding angles of AMB is congruent to the angle CMB. You following? So we've used those triangle congruences for reasons that can then take us out to the quadrilateral. If we summarize the proof, a rhombus is always a parallelogram, so the diagonals always bisect. Because the sides of a rhombus are congruent, the corresponding angles are congruent. Should sound pretty familiar to you by now. Let's try another proof. ABC is a rectangle. What do we know about it? Both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Mark that. Congruent and congruent. These are longer. All four interior angles are right angles. We know a right angle when we see it. See if I can just move that a little bit. And the consecutive angles are supplementary. So there's that word again, supplementary. Means two angles that add up to 180 degrees. 90 plus 90 certainly is 180. What do we know about the diagonals of a rectangle? Well, that they bisect each other. So if I just draw a simple basic rectangle, by definition of a rectangle, each diagonal is bisected. Here's our proof. So if ABCD is a rectangle, prove that AC is congruent to BD. What are we trying to prove? AC is this diagonal here, is congruent, shall I change colors, to BD. ABCD is a rectangle, that was given. ABCD is a parallelogram, and rectangles are parallelograms. AD is congruent to BC. Give those guys a little line here. And AB is congruent to DC. So where is AD? It's up here. BC is over here. They're congruent because opposite sides are congruent. Angle ADC is congruent to angle ABC. I'll just clear up those markings so we can see A again. From A to D. So we're really talking about this angle and this angle. They're both right angles, so they're congruent. And back to our triangles. ACD is congruent to triangle BCA. These are right triangles. Do you see it? And finally, your last statement and reason. You write what you're proving in the left column under statement, and then you give your reason in the right column. So the final thing that you've proven, AC is congruent to BD. It was become the hypotenuse of the right triangle, but it's also the diagonal in the rectangle, and your reason is corresponding parts of congruent triangles are congruent. Should be a little more familiar for you and you're more comfortable with this. Go on to complete pages 17 and 18 on your own. Have your work checked after completing page 17 before going on to page 18. You are preparing yourself for quiz number 3, naming specific types of parallelograms.